Hello guys, welcome back. I'm your friend Insect. So today we will do another learning of the Unity because as I think the learning is a habit, and if you cannot make it a habit, you probably won't be able to get to a very high level. Alright, let's go.
If you're watching this video, it means that you have completed the course. Congratulations, that is an amazing accomplishment. You've gone from beginner to now being able to create with code in Unity. So, you're ready to continue working on your own projects independently and expanding your skill set along the way. There are probably a ton of other features you're still hoping to add to your personal projects, like sound and visual effects, new power-ups and gameplay mechanics, a user interface to tie it all together, and all kinds of other features you've imagined. To help you with this, in this final section of the course, I'll show you some really helpful tips for using the Unity documentation and other online resources to figure things out on your own. In addition to that, I'll walk you through some suggested next steps if you're interested in putting your skills to the test on the Unity Certified User exam. Most important though, you should be really proud of yourself for getting to this point in the course. You have learned and created an astonishing amount, and if you wanted to pursue it, you are well on your way to a career in interactive development. I hope you had as much fun taking this course as I did teaching it. Congratulations again, and keep on creating.
Okay, to be honest, I didn't expect that I already passed this course. I didn't thought that this is the end of this tutorial. I mean the Unity official tutorial. But for somehow I did it. So let's say what he want to give us as an end suggestion. So the lesson 6.1 project optimization.
In this course, we've only ever used public or private variables, but there are a lot of other variable attributes that you should be familiar with. Now, I have prototype 1 open here, and actually what I'm going to do is instead of going anywhere in my scene, I'm going to go to my scripts. So I'm going to open up the scripts folder, and I'll open up my player controller script. Now, in my player controller script, I have all of these private variables. And if you remember, private variables can only be used within this class, and they can't be seen inside of the Unity editor. If I select my player object in my scene, in the inspector, underneath that player controller script component, you can see that none of the variables can be seen. In Unity, we actually have a very helpful variable attribute that you can use to see any private variables that you want to interact with. So I'll go to where my speed variable is created, and if I type a left square bracket, capital S, and write the word serialize, no spaces, capital F for field, and then I use a right square bracket. So now we have this serialize field attribute on our speed variable. What exactly is this doing? Well, if I save my script, and now when I open up Unity, you can actually see that under my player controller script with my vehicle selected, you can see that this speed variable pops up. So serialize field is a really helpful way of defining which variables you want to use just in the editor, but you don't want to ever use in a different class. So for example, if I have another class, another script that was using player controller, I want to be able to change this speed value in Unity, but I don't actually want to change that speed value in the script that's using player controller. And so that's a really helpful way that you can use serialize field to just edit variables that you just want to use in Unity itself. Just to show another variable that we can do this with, I'll also add this attribute to the turn speed. Make sure I save, jump into Unity, and now you can see turn speed can also be seen here. Now, if I open up my follow player script, in follow player, I can actually add this serialize field to our offset, save this, head back into Unity, and select my main camera. You can see now I can actually see that offset from my follow player script, and I can actually change this to whatever values I want. In fact, if I actually play this here and our script is running, I can actually move my camera to get different perspectives. So that's just a very helpful way of being able to change any of your variables without using public. Other cool things that I can do is change this private keyword. So originally we had public as another variable keyword we could use, which means that we could see this variable in any other script that used player controller. You can also use the keyword protected. And so protected is a mix of private and public. So with private, I can use this variable in this script, in this class, but I can also use this variable in any other script that actually inherits from player controller. So for example, player controller inherits from mono behavior, and so you can think of start and update both as protected methods, allowing us to use them in our player controller script. However, if we made a brand new script that didn't inherit from mono behavior, we wouldn't be able to use these methods. So protected allows you to see variables or methods outside of the current class, but only to any script or class that inherits from this main class. Other keywords that we can use as well are words like const. So in this case, private const float speed. And const is just short for constant. And so that means that we can never change the value of speed because of this keyword. So for example, I could not write speed equals 10 in start because speed is a constant variable that can never change. Other keywords that you can also use are words like read-only. So when you first instantiate an object and use the read-only keyword, you can set that variable when you create that object, but then you can never change it ever again, versus const is defined as soon as you create that variable. And static is another keyword that you can use if you want to have something like a global variable to use anywhere in your code at all times. So I highly recommend looking up what the different keywords like protected, private, public, read-only, const, static, serialize field, see what they all do, try to use them in your code, and try and do some exploration yourself. So what you're going to do is open up your Prototype 1 project, and you're going to go into both your player controller script as well as your follow player script. Once you have those scripts open, you can try to apply the...
Okay, if you ask me what I was thinking about, I think those features such as serialized field or private kind of stuff, it has no meaning to a game project as I think, because it doesn't necessarily have to be that complicated. If we can do it in a simple way, then we do it in a simple way.
In the course, we only ever use the default update and start event functions, but there are others you might want to use in different circumstances. In Prototype 1, you can see we have our start and update functions that are used when our game is started and then run while our game is playing. So when I press the play button in Unity, any objects that have scripts will then use our start method, and then as our game starts to play, it will start using our update method. To learn more about why these different event functions are important, we're going to make another camera. So I'm going to right-click on my main camera in my prototype. I'm going to duplicate it. So now we have main camera 1. I'm going to actually rename this to be secondary camera. So this will be the camera I use when I want to get the view right in front of our vehicle. I'm just going to disable my main camera by selecting it, going all the way to the inspector and clicking on that little blue checkbox. So now it's unchecked and it disappears from our view. You can see the camera preview went away. So I'll select my secondary camera. Now you can see the view here, and I'm going to put it right in front of our view. To do that, I'm just going to actually drag it into position here based on my camera view. There you go. So that's kind of cool perspective. You can kind of see the hood of our vehicle. And now I'm just going to take those values in the transform components and change the offset values from our follow player script. Now if I press play, and as I move along, you can actually see, as I'm driving this car, it's actually starting to jitter a little bit back and forth. And that definitely doesn't look very good. I could probably actually reposition this camera, but we'll keep it for now. And then as I run into these boxes, you can see the weird effects happening as I hit the boxes and actually colliding. So this is where knowing how to use event functions is incredibly helpful. Now, there are 2 event functions that we need to pay attention to, and this is all important for our update method. So update is one kind of event function. However, if we actually type the word fixed before update, we now have the fixed update event function. Now, fixed update is especially useful when you are trying to do movement and physics. Fixed update is actually called before update calls and actually happens when our game is trying to calculate any kind of physics that is happening when we're playing it. So if I save that, we'll then go into our follow player script. Now we're going to do something very similar to our update method, but instead of using fixed update as our event function, we'll use late update. Late update is particularly useful when we're trying to calculate the camera's position. And so you typically want to use late update when you have a camera that follows the player. That way our camera knows that all of the calculations for our player's movement is done. So this is definitely where our camera should go as the game is updating. Now if I save this, head back into Unity, I'll press play again, and now you can see that our camera, from this first person perspective, isn't really moving around anymore, which is awesome. It's not doing that shaky back and forth motion. And you can see when we hit these boxes, we're getting less of that rumbling effect when we're hitting them, and it's a lot smoother as we hit each of these different crates. So those are 2 powerful ways that we can just make our game a little bit more optimized. One last thing that we can do is in our start method, just to see a different method we can use, we can actually use another method called awake in place of start. And so start is useful when you have certain objects that are supposed to do something as soon as the game starts. However, there may be certain objects that you want to only do something when you want to use it. So for example, if you want a wall to move, you could use the awake method. So somebody presses a button, it will then call the awake method for that object, that wall, and then it will do something. So if there's certain values that you want to make sure are created when an object wakes up versus when the game starts, you can use the awake method. We're not actually going to use start or awake at all, so we can actually just remove them. That way our code is a lot cleaner. We'll save our follow player script. In player controller, we'll get rid of our start method. And so that way we don't have to get confused when we look at our code and see that we have 2 empty methods that aren't doing. So what you're going to do is in prototype 1, you're going to select your main camera, right-click, and duplicate it. So then you'll create a secondary camera. Make sure to rename it. We'll then make sure to disable our main camera. Now with our secondary camera, we want to move it into a position where it's kind of in a first-person view right in front of our truck. So in this case, I put it right in this windshield over here, so that way we have a cool effect over the hood. Once you've repositioned it using the transform property, you can then reposition it using the follow player script by changing the offset values to that position. Give your game a little test. Just see how the vehicle moves as you're driving through the scene. And then in your player controller script, you're going to remove your start method, rename update to fixed update, and then in your follow player script, remove start again, and then rename update to late up. And then test it once again back in Unity by seeing your secondary camera and watch how smooth the camera is. And then if you want, you can disable your secondary camera and re-enable your main camera. Now it's your turn.
Alright, now let's try it again. Here we go. First, we're gonna get into the first project that we have made in the past. Although I didn't record that kind of video, because back to then I don't have that kind of living space to record any videos. But now I got it, so let's do it. I don't know if it's in the challenge one. No, it's not. Oh, it's prototype one. And let me just okay, here we go. We got this little game. You know, we could play around. This is a tank, and it can go ahead this kind of thing. Okay, this is amazing, but we're gonna make it more like a first-person view. So here's what I'm gonna do. I'm going to duplicate the main camera and disable the first camera, rename the second camera to first-person camera. Alright, then we gonna let's say, oh, here we go. We should move the second camera for a little bit. Gonna move its position to something like this. Then we start this game again. Oh my god, nothing really happened. So why this is happening? Maybe we should go to the fellow player script and find it out. Try to find it out. So we go to the fellow player script. We select the edit script. It will open up a VS Code window. Inside of this window, you say we got a predefined vector. It's an offset from between the camera and or player. So to be honest, that's probably not a good way for doing it. I would more like, you know, just getting that when we start automatically. I want to automatically get that kind of offset. I don't know if this line of code works, but let's try it out. Okay, now if we start our code, we would say a view like this. It's kind of like a first-person view, but the rotation is kind of weird. Okay, for now, it's more, let's say, accessible for us. Okay, this is more accessible. And for now, if we move this kind of tank, you would say it's getting very stupid. It shakes like it shouldn't be shake like this. How do we fix it? Okay, we go to our code and we change this update to fixed update. Now, if we run this kind of tank, it's still shaking. So weird. Oh, I got it. We shouldn't change the update here. We should change it in the player controls, because it's the player control script really controls the tank's movement. So we should actually do that modification right in here. Now if we move again, as you can see, we got a smooth movement. The tanks no longer shake itself anymore, so that's great. And if we hit the box, it's also acceptable, so no problems at all. I feel okay with this kind of result. Now let's go on.
Throughout the course, we've created a lot of prototypes that instantiated and destroyed objects during gameplay. But there's actually a more performant and efficient way to do that called object pooling. So first you're going to open up prototype 2, and we're actually going to create a backup of our project. So I'm going to go up to the top menu, select asset, I'm going to export package, export. Now I'm actually going to export this package to my create with code folder. I'll call it prototype 2 complete, and I'm going to click save. Now we'll actually be overwriting a lot of our old work to use this new system. So it's important to make a backup first in case you want to revert back. Now the idea of object pooling works by creating a reusable pool of objects, a set number of them, that can then be activated and deactivated as they are created and leave the scene, rather than instantiating and destroying our objects, which means that our computer actually has to do more work to create a brand new object and then delete it. So using object pooling is much more performant by just having a set number of objects and then activating them or setting them inactive when we don't want to use them. In order to do object pooling, we'll actually import the object pooling package into our project. So on the webpage for this tutorial, you should see a direct download link for the object pooling Unity package. Make sure you download it. Now, you can add the object pooling Unity package any number of ways. I'm actually just going to do it using the assets option in our menu, going down to import package, custom package. In my downloads folder is where I saved that object pooling Unity package. So I'll select it and import it, and you can see that there are a couple of changes happening with detect collisions and player controller. So now if I go into my scripts folder, you can see that destroy out of bound is here, object pooler is here, player controller has updated. So first we're just going to double check and make sure that all of our different objects are set up properly. So you can see because of the change we made to player controller, it actually removed our script, so we just reapply that. On Spawn Manager, our Spawn Manager script is fine, and we're actually going to add the Object Pooler script to the Spawn Manager. I'm going to left-click, drag it, and I'll just drop it into the inspector. So you can see here now that there's a similar thing happening where we have pooled object, we have objects to pool, and we have an amount to pool. We won't worry about the pooled objects right now, so we'll just collapse this option. The object that we're going to pool is actually our pizza. So if I go to prefabs, I left click and drag pizza onto that little slot. And now I need a number of pizzas to pool, so I'll press 20, So now when I press play, oh, interesting. It looks like we're getting some errors down at the bottom here. That's kind of, so the reference script on this behavior is missing. So it says the animal doe, and it actually says it for all of our different things. So we're missing a script here. Now, from what I can see, we have our move forward and we have our destroy out of bounds, but we actually don't have the detect collision script anymore, so I'll drag it onto there. I select this moose, so they're all missing it, so I'm just going to apply all of these real quick. So now we can detect collisions. So when I press play, you can see in the spawn manager now, there's actually this expanding arrow that you can see all of the different food that we're pooling. And I'll go off to the side, and I can actually, you can see as I'm creating all of these pieces of food, it's actually setting them active and then setting them inactive as they leave our scene. And so now, we're not just creating and deleting an infinite number of pieces of food. We're only using as many as we need to use. So that way they're all created when the game starts, and then we don't need to ever delete them because we're just setting them inactive, but the player doesn't know any different. Now it's your turn. So you're going to open up your Prototype 2 project. You're then going to create a backup by going to Assets in the top left, Exporting Package, Export. Select a place that you want to export to. In this case, I'm actually exporting into my Create with Code folder, and I named my backup Prototype 2 Complete, so that way I know I finished it. Once that's done, I downloaded the object pooling package from the tutorial webpage. I imported that package into my project. Once I imported that package, I saw that player controller and detect collisions were both updated. As well, object pooler and destroy out of bound were both added as new script. In player, I made sure to add player controller back as a script onto that player object just to make sure it worked. I selected my spawn manager, added object pooler as a script, set object to pool as our food prefab, and then for amount to pool, I set that number to 20. A handful of other things I needed to fix. On each of my different prefabs, the detect collisions script unattached itself. So I needed to make sure that I selected each prefab and then added detect collisions as the script to use. Once I saved, everything should be working. So then when I press play, if you take a look at your hierarchy, you can see that Spawn Manager now has this arrow next to it with 20 different pieces of food. And then if I play my game, I can move my character. And as I create these pieces of food, you can actually see that they start activating and deactivating themselves as they leave the scene. Things that you can also do as well, try reading through the new code in the object pooler, detect collisions, and player controller scripts. Another thing to note, if your project is small enough, you probably won't see any performance issues. However, if you have a larger game, it is more helpful to implement object pooling, so that way you can avoid having any slowdowns in your game. Now it's your turn.
Alright, I do not think the object pooling is very useful for small projects. And even if you want to implement such a thing, you can do it by yourself, right? Instead of creating a new object and destroy it, you could probably activate it and deactivate it. That's all. So you can do it by yourself. You don't have to import a package or kind of stuff like that. So this is today's learning, project optimization. And I'll see you guys in the next day. Bye.